Okay, thanks very much. Today, I want to present to you about an agriculture-funded project called Forewarned is Armed that looks at providing new forecasts to the agriculture sector and also developing strategies for linking these forecasts to decision-making. And clearly, these forecasts are all ensemble forecasts. So the project uses the Bureau's seasonal prediction system, AccessS, and I just want to start by showing you what I found really valuable when talking to users. And that is to show them an animation like this to illustrate that the model is actually simulating the weather day by day, just like our weather forecast models. And then explaining that, because there's uncertainty in how the weather will evolve, we don't just run one of these simulations or forecasts, we run several, about 100 of them, and that this is called an ensemble. And that's how we generate the forecast probability. So for example, if 80 of those 100 are saying that there's going to be an above average rainfall season, then it's an 80% chance of being wetter than normal. And so we found that this really helps people understand where the probabilities are coming from and also understand that this isn't a statistical model. There's a lot of work that still needs to be done in this space with working with probabilities and ensembles and knowing how to actually use them in decision making. Most users want to know definitively, they want us to just say it's going to be wet or it's going to be dry, but we really need to get across concepts like shifts in the yards, risk, and a more risk management approach. So Forewarned is Found is a large agriculture funded project. And basically the aim of the project is to provide new sub-seasonal and seasonal forecasts of weather and climate extremes for agriculture. So we want to answer questions like, what is the chance of having an extremely wet season this summer, maybe a decile 9 or 10 season? Or what is the chance of having a heat wave in the week after next? So trying to get more information than just what is the chance of above, below median conditions or tercile conditions. And so in this project, we've got multiple research partners, you can see here, and also involvement and funding from several Australian research and development corporations like Meat and Livestock Australia, Dairy Australia, Wine Australia. And a key aspect of the project is that users have played a really critical role. They've been front and center, and engaging with users and co-design has been a very important component of the project because it really affects the utility, the understanding, the interpretability of any forecast products that we produce, and ultimately, will impact the uptake of new forecasts. So one of the things that I think is really exciting about this project and which really increases its effectiveness is that it has this end-to-end approach. So it includes underpinning science, forecast development, engagement with users, and how to interface forecasts to industry decisions, and then ultimately the delivery and extension of a new service. And of course, there are interactions and feedbacks between these components. And so our external project partners have taken the leading role in actually interfacing the industry decisions and development of risk management strategies. So firstly, the first aspect of the project I like to talk about, I call it the foundation. And it's the foundation of that's required for building upon any new forecast or issuing any new forecast. And that's really understanding user needs and the underpinning science. So at the start of the project, we had a series of workshops with each of the agriculture sectors involved, and they were aimed at understanding what are the main weather and climate risks, what are the main pain points, what are their key decisions, how might a forecast help them, what actions could they take, how far in advance would they need to know, and what are the sort of costs and profits associated with their decisions. And this type of information and feedback is really important and has been ongoing throughout the project. Another big component is the underpinning science. And this isn't blue sky science, this is a science that's really critical for us to actually understand the forecast system and understand how the main climate drivers are related to having extremes over Australia. And this understanding actually underpins the seasonal climate service and helps us to understand our forecasting, real-time forecasts. it informs the type of information that goes out to users, and also the confidence that we might have in forecasts for a particular situation. So this is an example of one piece of work that came out of the project led by Umpa and Harry Hendon, and Umpa actually already just presented this to you, and it's the influence that the stratospheric vortex above Antarctica has on the risk of us having extreme weather and climate over Australia. And basically, when you have stratospheric warming, then there's a heightened risk of having hot, dry, and fire danger conditions over Eastern Australia. But actually, as Umpa pointed out, all of this science actually came to bear in 2019, and the air above in Antarctica warmed unusually, and it was a driver of the really extremely hot and dry conditions we had, and the very serious fire conditions that we had in spring of that year. And not only were we actually able to forecast it, but the science that had been done gave us the confidence in the forecast and understanding of what was going on. So that helps with the communication then with users, and helps to develop trust between the service provider and the user. So one of the main aims, as already said, of this project is to develop and deliver new forecasts. And so the aim was to develop a large range of hot, heat, cold, and rainfall, subseasonal and seasonal experimental forecast products from AccessS, and make them available over a period of time on a research web server for trial and feedback. And you can see I've just put a screenshot of the web page there. Down in the left-hand column, there's the list of all the products that we developed. And then in the project, we actually have reference groups of different users in different sectors. So we had dairy, beef, sheep, grains, sugar, and wine reference groups. And they provided feedback to us of on these experimental products in terms of, were they able to interpret them? Would they be useful for their decisions? How might the look and feel of the products be improved? And then the aim was from that large set to pick 5 of them, the whole project to pick 5 of them, and then they would be delivered to Bureau operations and offered as part of the Bureau's service on its public website. And so today I'm going to show you the first 2 products that are actually destined to be part of the Bureau service at the end of this week. So the first one is for rainfall maximum temperature for the weeks and seasons ahead. And it's basically maps showing the chance of having very wet or very hot and very cold and very dry conditions. In other words, it's saying, what is the chance that you're going to have conditions in the top 20% or the bottom 20% of your climatological period? And the map on the left that I'm showing you there, that is what it looks like on our experimental R&D website. And then we had another round of feedback with those reference groups where the appearance is enhanced. So the colors, the actual words that are used, we don't want to necessarily use the word quintile. Users don't understand that. So what words we're going to use, what kind of about information do we need? And so the look and feel is refined yet again. The next product is our location-specific bars. So they're available for any 5-kilometer grid box over Australia. And essentially, they indicate the shift in probabilities compared to what you would normally have across the deciles. And so we've grouped the deciles into quintiles. So decile 1 and 2, 3, 4, 5, 6, 7, 8, and 9 and 10. And so normally, over your climatological period, you would expect a 20% chance of falling in any of those categories. And so then the question is, how does the forecast then change those probabilities? And you can see in the example that I've got here on the left, it's showing that there's an increased chance that you're going to have rainfall in this example for the month in a decile 9 and 10. So there's an increased chance that you're going to have a decile 9 and 10 rainfall month, and it's nearly double the usual risk. And equally, there's a strongly reduced chance that you're going to have very dry conditions. And we found that this kind of presentation really resonated with users, because suddenly they saw that, okay, yes, there's a strong shift in the odds towards having wetter, but actually, you know, there's still a chance you can get an outcome in the other categories. And again, so there's feedback again on that look and feel, and then it's refined for how it is going to end up being on the website. So then how can users actually best apply these sub-seasonal forecasts to their decision making? And this is a quote that's come from one of our users, which I really like. How do we use forecasts that are too good to ignore, but not good enough to be sure? And as I mentioned earlier, we've been trying to emphasize shifts in the odds and changing likelihoods. And I'm just going to give you one example of an approach that one of our past partners have been exploring. It's a way of thinking rather than developing or rolling out an app and tool. And the first thing to note is it's very decision specific. So in this example that I'm going to show you here, the decision is, should I plant vetch for my sheep to graze, or should I plant lentils that I'm going to harvest? And so the first thing to do, even before you start thinking about any forecasts, the first thing to get the producer or the farmer to do is to estimate how their profits would look like as a function of growing season rainfall. Okay, so here, for example, you have on the y-axis the profit, and then on the x-axis it's your rainfall season. So you're saying to the farmer, if you were to get a decile 9 and 10 rainfall season, what do you estimate your profits from planting lentils might be? And so if your graph ended up being completely flat, then it would be saying that, you know, a forecast of rainfall is not actually going to help you for that decision. So you do this profit and this profit against rainfall for both of the two decisions, and then you compare the two. So you compare the downside risk and you compare the upside benefit wedges. And you can see that the upside benefit of planting lentils far outweighs the downside risk. So under climatological conditions, you would mostly plant lentils. So the question then comes, well, what happens if a forecast comes along? And in this example here, I'm giving a forecast which now says there's actually a greater chance you're going to have drier conditions. We've increased the chance of it being really dry. And you can see how it shifts this graph. And but actually the downside risk increases. If you compare it to the graph on the left, there's more, the downside risk, the area of the downside risk increases. But actually there's still more benefit. The downside risk is still outweighed by the potential gains for if a normal or wet season eventuates. So this is the kind of thinking that is being workshopped with users to try to get them to think about a particular decision they're making, how that decision is actually tied to rainfall. And it's quite interesting because sometimes when you get people to think it through, they realize that actually they wouldn't change their decision based on a forecast. And also how accurate or how confident a forecast has to be to make them to change a decision. So what's next in our project? So as I said, those first two products that I showed you are actually going live on the Bureau's website at the end of this week. And then we've actually got the other 3 products that we've chosen, and they're going to go live next year. And so the one of them is a time series, which we call a climogram. It's either a weekly or a monthly time series. So you can see the box plots, which indicate the spread of the forecasts. And prior to that, it shows what was observed. And then in the background, it puts it in context of your climatological conditions. So you can see if it's unusually hot or if it's unusually wet. And so we're in the process at the moment of getting feedback on the look and feel of that product. Another product that was selected was probability of exceedance curves for rainfall. It's really interesting because we didn't think this product would be very popular because it's actually quite challenging for a user to understand. But in our interactions, we found that it was very popular actually. Once people understood the product, they really saw the benefit of being able to sort of select rainfall thresholds of interest and being able to slice and dice. And what's really become clear to us is that, you do need a hierarchy of complexity of information. Some people will never, ever be interested in looking at a product like that. But for some people who want to take a deeper dive into decisions, then it's important. And then the other product is what we've called a rainfall burst. And basically, it's just the chance of getting certain accumulations of rainfall over a 3-day period. So it's trying to get at whether or not you might have a burst of rainfall over 3 days rather than drizzle spread out, say, over a week or a fortnight. And that's been really popular for our northern producers over Northern Australia. And then lastly, there's a big emphasis over the next year on extension and training and communication because, these products are complicated. People struggle with probabilities. And so there's a lot to be done in this space. Thanks very much.